Okay, in this video we are doing Calc AB problem set 78. The problems and a playlist are in the description below. Let's see what we got. All right, use the table of values for the continuous function f to answer the questions. So this is like a new type of problem for the problem sets at least. We're approximating definite integrals using left sums, right sums, and trapezoidal sums, it looks like. All right, so we're going to go 0 to 10 using a left sum. So here's how I do this just from the table. Step 1 is to write down the integral and say it is approximately equal to. So this, much like when you approximate with a tangent line, you have to use the approximately equal to symbol, or you're claiming that it's actually equal and it's not. You're only getting like an estimate. So 0 to 10, f of x dx is approximately. All right, so from the table, what I do is I look at the x values. I'm like, all right, so that's 1. So that would be like the base of my rectangle. And then I'm using a left sum, so the height is going to be at the left endpoint from 0 to 1, which is at 0, so 3. And then we're going to go from 1 to 3, which is 2. And then the left endpoint would have given you a height of 5. And then we're going to go from 3 to 7, which is 4. And the left endpoint gives a height of 1, so times 1. And then finally we go from 3 to 7, 7 to 10, which is 3. I said that backwards, that's weird. The left endpoint would be 8. So we get this. Then you have to add all these up. So it's 3 plus 10 plus 4 is 17. Plus 24, I think you get 41. And then another really good option here, which I don't often do, but I mean I probably should, is you can create just like a scatter plot of the points. Like don't connect them with anything, just scatter plot. Put things in the correct relative heights or keep track of them somehow. And then you can actually draw your rectangles. I mean, so left rectangles, and you can see I did a crazy good job there. Then I found all the areas, and then you add them up, and you get your answer. I mean, it's a really good visual way of doing it. But more often than not, you're given the data in a table, so it's also useful to be able to get it like by thinking through the table. But, you know, whatever you want to do. All right, new problem, or new part. We're going to go from 0 to 7, using a right sum. So 0 to 7 using a right sum. Now pay attention to 0 to 7 because the table goes from 0 to 10. You could be asked for anything. You go 1 to 10, 3 to 7, 0 to 7, 1 to 10, whatever. Like you got to pay attention to what you're asked. So here, 0 to 7. And it's like I'm saying all of that. When I did check this over, I had gone from 0 to 10 again. So like I'm also kind of admonishing myself as I say that. So 0 to 7, we're going to use a right sum this time. So I'm going to do the same basic thing. This works better when you're only doing one sum on a table. If you're doing multiple sums on a table, maybe copy the table over again or something because it gets really messy. But we're going to go from 0 to 1, which is 1. And then the right endpoint, in this case, is 5. So 1 times 5. Now we're going to go from 1 to 3, which is 2. And then the right endpoint is 1. It's kind of like if you started out correctly, you're probably going to get it right, provided you have the bounds correct. Because it's very kind of algorithmic at this point. From 3 to 7 is 4, and then the right endpoint gives us 8. And then we are done because we're only going from 0 to 7. So you can see along the top, our little loops connect 0 to 7. We're done. So that's going to be 5 plus 2 is 7, plus 32, so I think 39. All right, now we could have done this graphically as well. Here's our scatter plot again. But remember using right endpoints. So when you're doing right endpoints, I usually start on the right-hand side, like do that part of the rectangle and then move to the left just to make sure the heights are correct. I find it a little weird to try to start on the left and be like, I think that's high enough. Just like go from right to left. So you can see we get a 5, a 2, and a 32, and we add them up, we get 39. All right, there's one more that we're going to do. So this is a new idea. It takes... this one, it doesn't take that long to get used to this, but once you're used to it, you kind of look forward to these problems other than the actual addition. Something to keep in mind is that on the actual AP exam, you don't need to add up the numbers. You just need to write out the sum. So if I can go back for a second, all you would have needed is 1 times 5 plus 2 times 1 plus 4 times 8. You don't need to add them up. It's probably a bad idea to try to add them up unless you're going to do something with that information going forward. I made a mistake on the 2022 videos where I'm solving them. As I'm saying not to add them up, I add them up and I got it wrong, and I got a lot of comments about that. So yeah, take the advice. Don't add them up if you don't need to. All right. I will say, though, in my class, you should add them up. I want to see the numerical value. We're not taking that shortcut. All right, 1 to 10, trapezoidal sum. All right, so we start off by writing the integral, and we say it's approximately equal to, you got to show that. If you don't show that, like, what are you even doing? Why are you doing this calculation, right? So it's approximately equal to, every trapezoid is 1/2 the height times the sum of the bases. So I'm going to start off with 1/2. Now, for the height, we're going from so we start at 1 and we're going to the right? So 1 to 3, that's 2. And then for a trapezoid, we have to add up the two heights, or the two bases, I guess. So 5 plus 1, so times 6. And that'll be plus 1/2 because every trapezoid has 1/2. We're going from 3 to 7, which is 4. And then we're going to add up the two bases. So 1 plus 8 is 9. And then we're going to do 1/2 because every trapezoid has that. We go from 7 to 10, which is 3. And we add up the bases, which should give us 12. Now, what you want to do if you do need to simplify this is always look for an even number that you can divide by 2 to begin with. So like for the first trapezoid, 1/2 and 2, those are gone, so it's just 6. For the second one, 1/2 and 4 is 2, so 2 times 9 is 18. And then for the third one, 1/2 of 12 is 6, so 6 and 3 is 18. So like always look for that. It can simplify it a lot. But also keep in mind, if this was the AP exam, you would stop here and you wouldn't even do it. But I'm going to do it. I think the answer is 42. We can also, of course, draw this. So drawing trapezoids is kind of fun because you just like connect the dots basically and then kind of put in the vertical lines. So we're going here, here, and here. And then these have areas of 6, 18, and 18. So that's the entire thing. I hope this was helpful, and good luck.